Hey there, today we're going to solve LeetCode number 26, remove duplicates from sorted array. So in this problem, we're given an integer array nums sorted in non-decreasing order. That just means it's sorted in ascending order, but there may be duplicates. And our goal is to remove the duplicates in place, such that each unique element appears only once, and the relative order of the elements should be kept the same. So to understand this better, let's head over to the examples. Given our input of this array, our goal is to remove the duplicates. So there's two ones, and now there's only one one. And our function should return k, with the first two elements of nums being 1 and 2 respectively. Does not matter what you leave beyond the returned k, hence their underscores. So we're allowed to leave anything beyond k. So anything beyond the first two elements, it does not matter because the LeetCode only checks the first two elements. Same thing here. We have all of these numbers, and our goal is to get the unique numbers essentially in the front, and in the end, it does not matter. And we also need to return, k, which is the number of elements that are unique. So to approach this, we can use the two pointers methods. So let's use this as our example. We'll have I and j pointer. The goal of the j pointer is to indicate what's going to be replaced if needed. So we can leave the first number alone because it'll always be unique. Because for example, when we start here at j, if this number is the same as this number, then we'll replace it. So we'll have j and I starting at the first index. I will be used to compare the number it is at and the number behind it to see if it's unique. For example, I here will look at itself and the number behind it, and if it's the same, then we know that it's not unique. So we'll move I ahead. And in any cases where there's repetitive numbers, we'll keep moving till we enter a new number. In which case, when we do find a new number, we'll replace that with where j was. So we'll keep moving forward, and when we reach 2, we'll replace that with where j was. And we move j forward 2 every time there's a number that needs to be replaced. So first thing we need is the range. So we'll have n equal to the length of nums, and we'll have j equal to 1. Next, we'll have a for loop for I in the range of 1 to n. So it'll cover all the numbers starting with here till here. And in this range, if nums of I is not equal to nums of I minus 1, so if I is not equal to the number behind it, then we'll replace it. So what we do here is set nums of j is equal to nums of I. And we also have to increment j, so we go to the next number that might need to be replaced. So j plus equals 1. And the interesting part here is we actually don't need an else statement, because if the number is equal to the number behind it, so if it is a duplicate, we just keep incrementing I to find a number that's not a duplicate. Now all we have to do is return n, which in case is our j, because our j is always in the position that might need to be replaced. So it's always right after all numbers that we know are sorted and unique. So it always gives us the number of elements in the list, because j was initially starting at 1. Now let's run our test cases. It passed, and let's submit. And yep, it passed too.